So let's begin with the first paper. In fact, it's not a paper. When I suggested, the organizer said, you are not allowed to present more than one paper. He said, well, this is not really a paper. It's a presentation of what we want to do in this world. And we began with the very idea of stratigraphy and why it's so relevant in archaeological research. An archaeological site is usually compared to a book or a cake to be eaten. And a book has pages, and the cake has different layers. You should read the book. But there is a main question that is really true that reading of this book or eating this cake really follows the order the book was written or the cake was prepared? Is there a universal time arrow to be followed when dissecting an archaeological site? Or stratigraphy implies other kind of orderings? That's not necessary that a stratigraphy always speak about time, specifically in case of archaeology. In a stratigraphic model, temporality is commonly defined on the basis of the distinction between two types of reference units. The stratigraphic unit is an empirical unit, some kind of distinction you are able to do when excavating the site, and the temporal unit, that is a subjective chunk of the time scale. And the definition of those both units differ considerably. The definition of temporal units on the one hand and of stratigraphic units on the other differs fundamentally. One refers to possible estimate of the relative time position of a certain event or related deposit events, and the other to a geometric partition of a volume based on empirical variables. And because of this different nature of temporal units and the stratigraphical units, we have a problem. How to relate different ways of segmenting the archaeological domain. This is the underlying problem with archaeological stratigraphies and usual methods of visualization, archaeological time, like the Harvest matrix, that with stratigraphy alone, we don't have enough for arriving to estimate time. And this is the main difference if you consider Allen Algebra or enhanced models of logically formatting temporal units and the logical order of stratigraphic units. It's not exactly the same, so we cannot translate one into the other. So I would like here to make some general discussions about how archaeological excavation should be. And I suggest to begin with an alternative view of archaeological excavation. Instead of digging and retrieving things, archaeological excavation is a question of measuring the variability of some properties. You are not excavating, but you are measuring things. And what do you measure when you excavate? There are sedimentary properties, there are petrophysical properties, there are engineering properties of sedimentary rocks and materials. That means it's a lot of geology, sedimentology, if you wish. But of course, archaeological properties. Then you have sedimentary things in general, and also the presence, absence of archaeological elements. For representational issues, we should take into account that any archaeological observation is a measurement of a space-time continuum, and you have different ways of understanding these things. Any archaeological observation then is a five-dimensional observation. We have three different spatial coordinates and two different temporal ones. You can ask why two different temporal dimensions because an archaeological event has duration, implicit duration. It's not something that happens just in a point of time, but along an interval of time. You need a variable indicating the beginning and another variable indicating the end. And then you have, with 5 variables, all the information you need to understand the pass of time and the formation process of the site. And there are 2 different ways of taking the information. In fact, you can use presence absence data, and you have a standard coordinates. That means x, y, z of the object. But you have also, in some cases, some radiocarbon, dendrochronological, isotopic measurement of time. And you can also obtain a kind of dissecting the archaeological space into sampling units. It's a kind of voxel model, if you wish, where each cubic centimeter has some information about sedimentary properties and also about time. Given that a cubic centimeter has 1 million, a cubic meter has 1 million cubic centimeters, and we're interested in measuring the archaeological space at the maximum resolution possible, that means that archaeological excavation as measuring implies big data. We need huge quantity of data, much more data that we usually take in usual excavations, because you have to measure each cubic centimeter as a minimum. Enough about data. We have extensively measured the archaeological space-time continuum. What we should do next? The answer is pretty obvious: to analyze the spatio-temporal variation. We have taken some variables, some of them are sedimentary, the others are archaeological, and we want to understand how it varies in this 5-dimensional continuum. Here, the notions of gradient, of discontinuity are of key importance. It's not just that you, when excavate, see a discontinuity, but you can reproduce the observed discontinuity using geostatistical and geometrical things. Really is different this part of the area. This is different to this other part of the area. Social actions generate transformations in the surface of space. And those transformations allow us to distinguish between areas. This is not just a question of technically detecting discontinuities, but understanding that some action produces some result, and as a result, the neighboring area will be completely different because this action was not take place on that part of the site. According to this, we could say we began with a very important definition. It's the idea of the positional event. It corresponds to the smallest units of physical space that can be differentiated with respect to neighboring things. If you are working depending on the degree of resolution, sometimes your minimum space is a room, sometimes it's a house, sometimes it's a activity area, anything that you understand in your excavation process, that is the minimum reference possible to indicate space. That means that we are defining the observability of archaeological events as a change of state in some global properties, archaeological and or sedimentary. The main important thing is that we use the concept of ground as the main analog of the empirical basis of a depositional event, because human action was present on the surface of the physical space. This surface has some characteristics related to the action performed there. Because ground is not exactly soil as understood in sedimentary or in geology, that we have to consider the official definition of soil and the definition of ground. And just in the middle, we have the main concept of surface to understanding our unit of analysis. In archaeology, we usually refer to living floors, to occupational floors, and this should be the unit of analysis. It includes the identification of the surface on which a human population acted and the study of all the remains and elements observed on that surface. The main problem is that occupational floors are very difficult to observe because of taphonomic and post-depositional aspects. You are not compelled to observe an occupational floor because probably it has disappeared. It has not well preserved. The solution to identify is using high-resolution microspatial analysis. The more resolution you have when you are taking measurements in your archaeological space, the better, because sometimes the only possible remnants of occupational floors are very tiny aspects of data. Sometimes using the precise placement of objects, using three-dimensional clouds, you can detect some surface or plane of the positional, and some other times what you have is micromorphology to understand some differences. What cannot be seen with your eyes can be detected using the microscope. Why is so important to identify the occupational floor? Because an occupational floor can be understood in terms of surface. And then we can define the depositional plane. And the depositional plane has all the meaning we have to understand the social activity and the history of the site. Here you have plenty of different examples of how to detect depositional planes and using computational methods to visualize these things. But another important aspect of taking occupational floors as surfaces is that we can use geomorphological tools. We can measure the surface and then indicating what happened on that surface. The idea of derivatives, flow actions, slope, action, and understanding the taphonomic process that may have occurred at that surface. So the main idea is the evolution of the site and trying to relate one occupational floor to the next one. Why is so important? Because the end of a depositional event is not exactly the moment of the next one. That is important to understand that the decomposition of the archaeological site is not a volume, but a series of surfaces. And sometimes we don't know exactly the quantity of time between one floor and the next one. Here is where it arrives the importance of time. We have to order a sequence of surfaces indicating the pass of time and the length of the interval between different surfaces. Of course, there are plenty of ways of using the techniques, and this is what we want to do in this session, that to obtain different visualization techniques to understand how different surfaces are related. There is not a single one. It should be analyzed in each case. And then understanding how different surfaces are related. Sometimes there can be more or less contemporaneous, sometimes they are completely different. The result is not just a decomposition into layers, but a decomposition into depositional events, and with plenty of time relationships within it.